Now let's continue with the derivation for the mean and the standard deviation of the binomial distribution. In my last session, we have discussed what is a binomial distribution, and also we have seen what the binomial distribution function p of x is. So the p of x for the binomial distribution is ncx, p raised to x and q raised to n minus x. Okay, so where p is the probability of success and n is the probability of failure, and n is the number of times the experiment is repeated. Okay, so now let's work for the mean. Mean mu is equal to, by formula I have given you the formula. It is x going from 0 to n, x into p of x. So let's substitute the value of p of x over here. It is summation x going from 0 to n, x into ncx, p raised to x, q raised to n minus x. You will get it like this. Or summation x going from 0 to n, x into n factorial divided by x factorial n minus x factorial p raised to x, q raised to n minus x. Just substituted the value of ncx over here. Okay, now further you can simplify this accordingly. Now from this you can cancel one of the x from here. Okay, so you get this as summation n going from x going from n 0 to n. So now when you cancel this one x, okay, you have to write x going from 1 to infinity. X is got cancelled, so the numerator will be as it is, n factorial divided by x minus 1 factorial n minus x factorial p raised to x, q raised to n minus x. Okay, now this we will split accordingly. So I can summation n x going from 1 to n now, because already x is got cancelled. If I put x going from 0 to n, it will be minus 1 factorial, and minus 1 factorial is not defined. So x has to go from 1 to n. Okay, this we will split as n into n minus 1 factorial, p into p raised to x minus 1, q raised to n minus x, because it is x minus 1 factorial appearing over here. So wherever it is x, I am replacing it by x minus 1, so that we get the proper way of writing it. Okay, n minus x, it's factorial, and further n into p, I'll take it outside. Okay, summation x going from 1 to n, n minus 1 factorial as it is, p raised to x minus 1 as it is. Okay, x minus 1 factorial, this denominator I'll write it like this, n minus 1, because it is n minus 1 in the numerator, minus x minus 1 we can do, adding 1, subtracting 1. Okay, take it in bracket, its factorial we are considering, and whatever I did with n minus x for the denominator, I'll do it the same thing for the new power of q. Okay, so n minus 1 minus x minus 1 I can write. Okay, so it will be like this. Now this is nothing but n into p, summation x going from 1 to n, n minus 1 c x minus 1. This whole expression is n minus 1 c x minus 1, p raised to x minus 1, q raised to n minus 1 minus x minus 1. This is as good as writing n into p, p plus q raised to n minus 1. Okay, p plus q is 1, raised to n minus 1 is also 1 to the power is also 1, so it will be n into p. So the mean mu is n into p. We have derived it up till here. Okay, now let's work for variance. Variance v is equal to, variance v is equal to, I have given one formula to you, that is summation x minus mu whole square into p of x. This is the formula, x going from 0 to n. But I'm not going to use this formula for evaluating my variance. I will use instead this formula, because it goes easy with the derivation. So x going from 0 to n, x square into p of x minus mu square. We'll use this formula for variance evaluation. So please make a note, we are going to use this formula for the variance evaluation. Just see here. Okay, now let's derive the variance v and then the SD for binomial distribution. Now we have the formula, variance v is equal to summation x going from 0 to n, x square into p of x minus mu square. So this is the new formula, you need to make a note. variance we can also be evaluated this way. Okay, now I will only consider the first part. Mu square we know, mu we have found it is n into p, so it's not a problem for us. Only concentrate on the first part of the expression. So let us consider summation x going from 0 to n x square into p of x. So p of x is already there, so we'll substitute it. Summation x going from 0 to n x square into ncx p raised to x q raised to n minus x, or further when you write it, it will be equal to summation x going from 0 to n, okay, x square n factorial divided by x factorial n minus. Okay, but before going for this simplification, I'll not do it the simplification like this. 1 minute. I want to replace this x square by thing. Okay, I'll write it here. See, without that we cannot go further. See, I can write my x square as x minus 1 into x plus x. Can I do it like this? X square can be written as, okay, x square can be written as x into x minus 1 plus x. Okay, just see, x square minus x plus x. So you still have x square. So I can replace x square by this bracket. So let us do that. So it is x into x minus 1 plus x into p of x. Before substituting what is my p of x, I am doing it. Okay, this is my work to show you that x square is this. So we are replacing x square by this bracket. So into p of x we are having. So now accordingly we'll separate it. Okay. Now why we are doing this? Because see, x square cannot be directly cancelled from x factorial. But if I split it like this, x into x minus 1. What is x factorial in the denominator? It is x into x minus 1, x minus 2. So at least these two brackets and x both will get cancelled from the denominator and the numerator. So for that reason we are splitting x square like this. Okay, nothing else. So now this is equal to summation x going from 0 to n. X into x minus 1 into p of x plus summation x going from 0 to n x into p of x, that is this complete thing multiplied with p of x one summation plus this x into p of x into the summation and all that. Okay, now next substitute the p of x over here. X going from 0 to n, x into x minus 1 n factorial. Okay, right, let us write it as ncx p raised to x q raised to n minus x. All this stuff you know very well. There's nothing to repeat. Okay, p raised to x, we are just substituting p of x over here. Okay, then further let us simplify. ncx you can write it as n factorial divided by x factorial into n minus x factorial into p raised to x into q raised to n minus x plus. Now this thing we have already done, x into p of x. I need not simplify it. It is nothing but n into p. We have done it already. X into p of x is nothing but mean. Yes or no? This we have already done. So I'm not going to vary. I'm not going to change. Only this we need to evaluate. Okay. So pay attention over here. Now x factorial can be written as I told you. X factorial can be written as x into x minus 1 into x minus 2 factorial. Okay, so x into x minus 1 from the denominator and from the numerator will get cancelled. So you'll get summation x going from, when you cancel it, you will have x minus 2 in the denominator. So you cannot take x varying from 0 to n. You have to take x varying from 2 to n. Okay, so you will have n factorial divided by x minus 2 factorial, n minus x its factorial, p raised to x, q raised to n minus x plus n into p. Okay, now since x minus 2 is, you are getting the simplified one, accordingly we have to adjust all other terms in the numerator and in the denominator. See, look at this, it all depends on x minus 2, whatever you have. Okay, summation x going from 2 to n. Now I can write n as n square. Okay, 1 minute. I can write n as n into n minus 1 into n minus 2 its factorial, and I want to write, because it is x minus 2, so I have to go up till that value only. So n into n minus 1 I'll take, separate it. Okay, and this p I can write it as p square into p raised to x minus 2, and q I can write it as q raised to n minus 2 minus of x minus 2. So the same I have to do in the denominator. The same thing we had done in evaluation for the mean. Okay, we had adjusted. I hope you remember. Okay, so we are doing that same thing now here as well. Okay, so x minus 2 you have the factorial, so this denominator also n minus 2 minus x minus 2, you are adding 2, you are subtracting 2, nothing else, plus n into p you have. Okay, now n into n minus 1 into p square, you can take it outside the summation sign, remaining whatever is left 2 to n, n minus 2 factorial is left, p raised to x minus 2 is left, make a difference here, don't mix up the terms, q raised to n minus 2 minus x minus 2, okay, divided by x minus 2 factorial and n minus 2. I hope it is seen there. I need to continue it here 1 minute, otherwise you won't be able to see anything. Okay, I'll just continue the rest part of the derivation over here. Okay, just a minute. So far we were doing for summation x going from 0 to n, x square into p of x we were working, and we had got it to be n into n minus 1. I had asked you to take it outside, remaining everything you keep it inside. X going from 2 to n it will be, so n minus 2 factorial you have in the numerator, p raised to x minus 2, q raised to n minus 2 minus x minus 2 you have. Please make a note. That divided by x minus 2 factorial, n minus 2 minus x minus 2, its factorial, plus n into p you had. Just make a note. This is what you had. Okay. So this is different. Don't mix it with that. Okay. Now n into n minus 1 into p square. Okay. And this thing is nothing but summation. Okay. I'll write it. Summation x going from 2 to n. nc2 n minus 2 c x minus 2 you can write. Okay, and p raised to x minus 2, q raised to n minus 2 x minus 2 plus n into p you can write, or, and this thing is nothing but p plus q raised to n minus 2 plus n into p. This complete thing is p plus q raised to n minus 2, like how it was previously. Okay, now this p plus q is already 1, 1 raised to n minus 2 is always 1, so you will have n into n minus 1 into p square plus n into p. This as the this first part. Okay, but variance v is equal to summation x square p of x minus mu square. Okay, so let's substitute the value now. This complete first term was evaluated to be like this: n into n minus 1 into p square plus n into p minus mu square. Okay, like this it is. So it will be equal to let me get this n inside and multiply p square. It will be n square p square minus n into p square plus n into p minus mu is n into p. N into p whole square is n square p square. Now this gets cancelled. You can take n into p common. It will be 1 minus p, or what is 1 minus p? It is q. N into p, q you get. This is the variance v. Okay, so variance v is equal to npq. Okay, I want the standard deviation sd. Okay, the standard deviation sd, which is sigma, it's the root of the variance. It will be root of npq. I hope this is clear to all of you. This completes the solution for this derivation of the mean and the sd of the binomial distribution. Continue in my next session.